In this section we're going to talk about adding polynomials. In the previous segment on collecting like terms, we're working on either adding or subtracting individual terms or individual shapes like x or x squareds. And we were asking them to put them together with the instruction to either simplify or to collect like terms. And today what we're going to talk about is, instead of adding or subtracting individual terms or individual shapes, we're going to add together groups of shapes. And if you recall, a group of shapes can be called an expression. So what we're going to do today, we're going to talk about collecting individual terms, but we're also going to be talking about collecting groups of terms, which is called an expression. So we're going to be adding and subtracting expressions together. Before we can do that, we have to start having an understanding of what this parenthesis, some people call them brackets. Normally brackets are the square brackets. These are parentheses. What does a parenthesis really mean? What does it connote? What does it tell us? And one of the ways that I like to think of it is, I like to think of it as a set or a group, or possibly even something like a box. So if I have a box of something, I have things inside the box. And if I have more than one box, I have more than that set of things that are inside the box. So we'll do a quick example of what I'm talking about here. So let's say in my box, or inside my parentheses, I have an x, and I have, I don't know, say a couple of these guys. So we have an x and two positives, so x plus 2 inside my box. How might we go about saying I have three boxes? Three identical boxes, each box having an x plus 2 in it, and I have three of them. So we would write that down something like this, showing that in my box I have an x plus 2, and out in front of it I have 3. So since we have to talk about making sure that we understand if there's a number and there's a term beside it, so this box can be thought of as a term, and there's no symbol between the number and the term, that means multiplication. So if we have three boxes, we could say that we have three sets of these parentheses. That means we have three sets of x plus 2. What would I have altogether then? So my diagram might look something like this. And altogether, what do I have? If I want to say simplify, then instead of writing it in this multiplication format, I want to find out how many x's I have and how many individual numbers or constants I have. So I could say that I have 3 x's, 1, 2, 3 x's, and 6 individual numbers. So I could write this as 3x plus 2, or I could write it as 3x plus 6. And so what we call that is the distributive property, and so we want to make sure the students understand that I have 3 sets of the x, and there they are there, and I also have 3 sets of the positive 2, and then they are there. So I've distributed the 3 across the bracket, and now I have no bracket, so my expression would look something like this. And now I have collected my like terms. I've got all my x's together, I've got all my constants together, I've removed my bracket, and the only way that I can remove a bracket is by multiplying, and so there it is there. I've simplified that expression. In this question I have an x, and I have 2 sets of x plus 1. So what would that look like as a picture? So my diagram might look something like this. I have my x, and I have 2 sets of the x plus 1s. And if I want to simplify it, I want to get rid of this bracket up here. And so I could say I want to distribute the 2 across. So I have 2 times x, and I also have 2 times 1. And so in my pictures here, I want to just collect all my like terms I have together now. How many x's would I have altogether, and how many individual constants would I have together? So my answer would look 3x plus 2, and just showing what that would mean, I take my x's now, altogether I would have 3 x's, and I take my individuals, and I have plus 2. So I distribute that across, I now have x plus 2x plus 2, and I combine them all together and I get 3x plus 2. On this question I have 2x plus 2 plus 3 times x plus 1. And I notice that I've got 2 different kinds of boxes here. I've got 2 sets of boxes, but in this box I've got an x plus 2, and in this box I've got a different one which is an x plus 3. And the instruction might be simplify and collect like terms, or it could just say simplify. It could be expand and simplify, or it could be expand and collect like terms. And when we say expand, that means get rid of the brackets. So let's quickly show with the pictures what would this question look like. And so visually this is what this looks like. I have two of these boxes, so in every box I've got an x plus 2, and I've got 2 of those, so there's my 2. I've got x plus 1s in these boxes, and I have 3 of those, so there they are. And I could put a plus sign between all of these to tell me that I have to add them all together. So it could look like that. And so now that I've got all my pieces drawn out, I can go ahead and collect like terms. And so I'm going to put all the x's together and all my numbers together, and I'll show what that looks like. It would look something like this, and now that I've done that, I don't really need to have my parentheses anymore, so I can get rid of those. So it would look something like that, and if I wanted to write it out, it would be like this. I've multiplied to get rid of my brackets. I've distributed, so there's my 2x and my 4, so 2x plus 4, and positive 3 times x, and positive 3 times 1 gives me 3x, positive 3x and positive 3, and then combining all the like terms, I get my 5x plus 7, which is what I have up here. So to review, to get rid of my brackets, I have to multiply by the thing out in front, or I can draw out my pictures. Once I've drawn out all the individual pictures, I can then collect like terms. So in the shortcut version, instead of drawing out all the pictures, I can distribute across from the number out in front times the thing inside the parentheses or inside the box. And in this example, we have the same kind of thing, except we have a slight variation. There is no number out in front of the bracket here. So if I have no number out in front of the bracket, does that mean I have nothing in my box? I have no boxes. Well, clearly I have a box. I've got an x plus 1 inside the box, or I have an x plus 1 inside my parentheses. So if I don't have a number out in front, what does that mean? Well, this is a perfect example to say, well, if I've gone to the bother to tell me what I have inside my box, I must have at least one of them. So that would imply that I have a number out in front here that's not being shown, and that number would be the number positive 1. And so the same thing happens here. Inside this box I also have an x plus 1, but it doesn't show that I have a certain number of boxes. Well, if I went to the bother of writing down what I have inside my box, I must have at least one of those. So now I can say that I have one box of x plus 1 plus another box of x plus 1. So in pictures it would look something like this. And now to collect like terms, I can go ahead and collect the things that are the same. So I've got an x, and I've got a 1 and a 1, and now that I've done that, I don't need my brackets anymore, so I can remove them. So my picture would look something like this now, and I can rename that as 2x plus 2, with the following work being shown. Here's my 1x plus 1 and 1x plus 1 without my brackets now, because I've distributed it across. Once I've done my distribution, my bracket goes away. So now I'm still left with 1x plus 1. 1 times 1x is 1x. Positive 1 times positive 1 is still positive 1. Now that I have no brackets, I can collect like terms, 2x plus 2. So even when I don't have something out in front of my bracket, I actually do. It's probably an invisible 1. And our final question here is x squared plus 3x plus 2 times x squared plus 1 plus 3 times x plus 1. It looks kind of complicated, but let's just work our way through with the pictures and it'll make perfect sense hopefully. My diagram looks like this. I have an x squared, there's my x squared. I have 3 x's, there's my 3 x's, 1, 2, 3, plus 2, plus 2. I've got 2 sets of this in my box, so there's my box, and in each box I've got x squared plus 1, another x squared plus 1, and then I've got 3 sets of these boxes, so x plus 1, x plus 1, x plus 1 3 times. So now that I've drawn out my boxes, I can collect all my like terms and remove my brackets. So I've shifted everything over to the side. Now I'm going to remove my brackets, and I can count up all my pieces to see what I have. And the work to show this might look something like this. So I've got my x squared, 3x, 3x, 2, and a 2. Nothing's changed there because there were no brackets here. Here I've got sets of things, so I distribute it across, so I get my 2x squareds. I've got positive 2 sets of positive 1, gives me positive 2. I've got positive 3 sets of positive x, gives me 3x, and positive 3 sets of 1 gives me positive 3. Now that I've done my distribution, I have no brackets, and now I can go ahead and collect like terms. And I get 3x squareds, there they are there. And here they are here, 1x squared and 2x squareds. I've got 6 x's, there they are there in my picture. And here's 3, and another 3 gives me 6. And here's my 7, there's my 7 x's, my 7 single units. And there's a 2 plus another 2 plus a 3 for a total of 7. So that's the work you might show to show your work. And so there's our question. We might want to keep that kind of arrows to show that you've distributed the number across the box or the brackets. There's my sub pieces without all my brackets, and here's my final answer with all my pieces collected together in order from the highest exponent down to my lowest exponent. So we've done adding polynomials and simplifying them, collecting like terms.